All right. Well, hello, everyone. Before we get started, do you guys have any questions for me on week 2 or any information from the last couple weeks? I believe ProctorU is the choice for this class. They were using Criterion, and I believe they switched it to ProctorU, but you can email the testing center to know for sure. I wish I could be more helpful when it comes to proctors, but other than telling you that you need a proctor, that's like the limit of my capabilities, I guess. The testing center does all approval, all communication, all recommendations, all that. So I would suggest that you just verify with the testing center what proctor can be used for this class. But I am thinking it is ProctorU. All right. Any other questions you guys would like me to answer before we get started? Well, okay, so what we have here is, because I'm joining 2 classes together, one class, it's your actual, for one class, the meet session actually belongs to that class, and for the other class, you're like a guest, so however you enter your name, it comes up as that. As long as, you're paying attention, since there's no attendance or anything taken at the meet session, it's not necessarily important that I have your full name in there, but the only downside would be is if you ask a question, I just have to say, well, DW, the answer, you know what I mean? Like I can't refer to you by name, but as far as attendance and things, it doesn't impact it for that at all. All right. So it's 8:30. We have a whopping 64 slides to get through today, so I am going to jump in here and just get started. But don't, ask questions. If you have questions, don't worry. I mean, if we can't get through all of them, we can't get through all of them. A lot of them are examples, and I'll know when to speed up. But so don't hesitate to ask questions. Those are very important. All right. All right, so we're going to talk about encapsulation and abstraction, which are 2 key concepts in Java, and those definitions will be on both the midterm and the final. So definitely concepts you want to make sure you understand. We're going to write simple classes and methods, test cases, and Java docs. So this is week 3. This is going to be kind of the last time that we're going to go over this same material again. If you remember back in week 1, I said, don't worry if you don't get this. We're going to go over it again and again. So this is the again and again part, and then we're going to move on from here, and we're going to start introducing brand new concepts from week 4 on. All right. So encapsulation, the definition of encapsulation is the hiding of implementation details. And this is what makes Java such a secure and language, is that it doesn't reveal its secrets to other people. So when you write a class, we define things as private so that only the object would have access to that particular data. And then in order for other people, programmers and things, to get access to the data, they have to go through the object. So the object itself controls all access to its data. All right. So if we go back to the whole blueprint concept, do you have to have the blueprint memorized? Do you have to know exactly the blueprint in order to be able to live in your house? Absolutely not, right? So, and the same thing goes with the class. You don't have to know how everything is programmed. Like if we were to take the string class, for instance, you don't have to know all the code behind the string class in order to create an object of data type string or to call the methods on data type string. We just need to know what our interface is, and that's what encapsulation is. All right. Do you need to know how everything is wired in your house to be able to turn on a light switch or to plug something into an outlet? Yeah, again, no. So you just need to know that the premise behind a light switch is that it turns something on and off, right? And that the premise behind a plug is if you plug in, you're going to get electricity. So you just need to know the basics of it, but you don't have to know how things are behind the scenes. Okay, so the same thing goes for a class. And I was always saying, I don't need to know all the code inside of the class in order to use it. So for instance, the menu class that you were using in this homework for week 2, you didn't see any of the code for that, right? You went out and you looked at the Java docs and you could see what constructors were available and what methods were available, but you didn't actually see how the class was written. And yet we could still use that information to create a menu object and to add items to that menu object and so on. And so that's where our Java docs come from, and you guys use the Java docs to look up the menu class. And we also took a look at the string class in the Java docs where we could see the different methods that are available for the string class. And for any class that's out there in Java that's not user defined, that's not specific to the industry in which you're in. So if it's generic stuff, you can go out to the Java libraries and take a look at these Java docs and be able to see what's going on. And hopefully whatever company you're in would have its own internal Java docs that you could also refer to. All right, so that's encapsulation, hiding of implementation details. All right, abstraction, on the other hand, is abstracting things down to a single concept. Okay, so I want to make sure I don't jump the gun here. All right, so if you were building a house in a barn, is this going to be one building or 2 buildings? Okay, so we had a great question here. It says, does open sourcing a project nullify encapsulation? Yes, because now things are no longer hidden, right? They're all open. So good question. All right, so yes, so this is 2 different things. A house is one thing and a barn is something completely different. Okay, so would we have just one blueprint that would apply to both the house and the barn, or would we create 2 separate blueprints, one for the house and then one for the barn? Yeah, absolutely separate blueprints. And so we wouldn't want to create a class that was called house and have it apply to a barn as well, right? We would want to have 2 completely separate classes. So out where I live, everybody has, 2 to 5 acres, and so a lot of people have barns out here, but they're not the same, right? So I wouldn't want to have one blueprint that was a house and a barn together. I would have 2 completely separate, and that's abstracting things down into one concept, making sure that whatever class you create just represents one entity and not multiple entities. Okay, so for example, if we were creating a pet store, we wouldn't want the pet store class to define the store and then all the pets inside of the store all in one class. We would want one class that defines the store and then a completely another class that defines the pet. Okay, the same thing goes on for, like, if we think of the students, it used to be way back in the day, we'd try to cram as much stuff as we possibly could inside of one file. All right, so we would cram all this stuff in there, but then what you found is it was very limiting. So we would try to have the students and the address and all of their grades and all of their classes and everything inside of this one location, and it just got horrendously messy, and we weren't able to, and then we didn't have flexibility either. We were limited in what we can do. So by separating these things out and saying, here's just the student demographic information, which would be the things about the student that doesn't usually change, like their date of birth and their gender, that sort of stuff, their student ID. And then you'd have another class to hold the addresses, because you could have multiple addresses, right? What kind of addresses might a student have? A dorm address, a home address. They might have an emergency contact address for someone, right? So even though those are three different addresses, an address is an address, right? You're going to have a street, potentially a PO box, a city, a state, and a zip. So you can create one address class, but then use multiple instances of it. So you can create one object, one address object, and let that be the emergency contact, and create a different address object and let that be the student's home address, and a different address object, and let that be their on-campus address. Okay, and so that's what abstraction down is, kind of getting things to represent just one single entity or one single concept. So encapsulation is hiding implementation details, and abstraction is taking things down to just a single concept. All right. So just kind of going back over this stuff again, a blueprint, a class is a blueprint. So nothing lives in the blueprint, no data, there's no objects inside of a class, all right? But you can use a class in order to construct a house or to create an object, okay? So you can't store any data in a class, but you can use a class to construct an object, and an object can store data. Right, so I know there's like this nuance when the book gives you the definition of a class. It says that a class describes a set of objects, but it doesn't say a class contains a set of objects. And that's a very important distinction, because a class is the blueprint that tells you all about those objects. So it does indeed describe all of the objects that are created from a class, but a class itself does not contain any objects. Objects are created from a class. They aren't contained within a class, because a class cannot store data. All right. So our components of the class, just going over this stuff, are instance variables. Well, they're not of a class. They're the blueprints, right? The components of the blueprints that are used to create the object are instance variables. And this is the data that we're going to be storing inside of our object. Okay. Constructors, which are used to initialize those instance variables and define an object, and then the methods that are used to manipulate or access the object data. So there's set methods, which change the values of the instance variables. There's get methods, which retrieve values of instance variables, and then there's other methods that could be a combination of those two. Okay, so these are defined in the Clasher blueprint, but all of these things exist inside of the object itself. So the methods belong to the objects, all right, and they're actually built in. So what you end up with is this super data type that contains not only data, but also contains these methods, these actions that can act upon the data as well. All right. So instance variables can also be known as attributes, right? And this is the information that we need to know about an object. We define them as private, which is encapsulating this information so that no one outside can access those instance variables directly. They have to go through the methods in order to access the data. And that's really key in Java. By forcing them to go through the methods, then you can validate data, you control how your data is accessed and what can be returned and what can't be returned. Okay. So for an example, we have our dog class, and we would define our instance variables as private, string dog name, private string breed, and private integer age. Okay, so by defining these as private, we've encapsulated them and said the only way to get to this information is through the methods that exist within our object. All right. So don't hesitate, guys. If you have questions in here, just pop them on out there. All right, constructors are used to construct an object, and so they do that by initializing the instance variables to values. Now, they may initialize them to default values if it's an empty or default constructor, meaning the parentheses are empty, or they may initialize them to a specific value if the constructor defines explicit parameters inside of the parentheses. Okay, so the empty or default constructor has no explicit parameters. Those parentheses are empty. These PowerPoints are available in the meet session. Is that what you're talking about? I also went through a whole example of how to create a class and then use a class as a data type during the week 1 Q&A session, which was recorded, and you can view that recording as well. And that may be helpful to try to draw some of this stuff together. And then in the that was the week 2 Q&A session that I went through this whole big example. I created a class, and then I created an actual program that used the class itself to generate information. In the week 3 Q&A session, I went over lab 1 in like minute detail. So that would also be another place to be able to see how some of this stuff ties together. And those recordings are posted out in the week Q&A session as well as on Piazza. Great. That's perfect. Perfect question. I'm sure other people were thinking the same thing. All right, so the empty or default constructor, the whole point is to set those instance variables to a default value. And the default value would be defined by the program design. So whoever is giving you the design of the program would say these are the default values, okay? So an example of writing the constructor in the class, so in your blueprint, is it's going to have the same name as the class itself, and there is no return type. So it's public dog with an open and closing parentheses, nothing in them for the default constructor. And then we set each of the instance variables equal to whatever the default value is. So in this case, we chose unknown, unknown, and 0. So we reference the instance variables with the keyword this.name, this.breed, this.age, and we set each one of these equal to a 0 or to a default value. Okay. The keyword this is considered an implicit parameter. We talk a lot about explicit parameters, but the keyword this refers to an implicit parameter, and what that is it's implied. So the keyword this refers to the object that you're actually creating or the object that you're manipulating. So when you see the keyword this, it's talking about, oh, the object that I'm creating here. Okay. All right. The explicit constructor, on the other hand, is going to have values actually passed to it within the parentheses, and those values are what's going to be used to set your instance variables to. So in this case, we have public dog, so it's exactly the same start out, but the parentheses are not empty. And inside of the parentheses, we are identifying our explicit parameters that we're expecting when this particular constructor is called. So in this case, we have 3 explicit parameters. The first one's data type string, the second one's data type string, and the third one's data type integer. And when the values are passed in, we're going to expect the first string value is going to go into this variable in name. The second string value is going to go into this variable in breed, and the third string variable is going to come into this variable in age. And so then we can set our instance variables equal to each of those. So whatever value was passed in when we called this first one is now going to be assigned to our instance variable this.name. And whatever value was passed into the second position will be in our variable in breed, and then we set that equal to our instance variable this.breed, and likewise for the age, we'll set that to this.age here. Okay. Now, to create the object, you're going to call the constructor. Now, I don't want to say you never, but you're not calling the constructor to create an object inside of your class, inside of your user-defined data type, right? This is going to happen in a completely separate program where you're actually using your data type. Okay, so that's a great question. So I talked about an explicit constructor and then or a default or empty constructor and then the explicit constructor. And so the question is, we usually want both. Most of the time you probably are going to have at least 2 constructors. In lab 1, we're only going to have the 1 constructor for that particular scenario, so not always, but I would say most of the cases you're going to have at least 2. You may even have 3 or 4 constructors depending upon the type of program that you're writing. But yeah, I would say most of the time you're going to at least have 2, one that is the empty or default and one that contains something for all of the instance variables. Okay. So when you're calling a constructor, It's in a completely different program. All right, it is not in your class. It's in a main method program where you're actually going to create objects and you're going to manipulate the objects and all that. Remember, the class where we're defining the object is all about the blueprint as to what this object can look like. So we're not going to create an object inside of the blueprint, right? You're going to create it somewhere else. So the basic format for the constructor, so we have this public statement, right? Public constructor and then whatever the explicit parameters are. And to call it, it's class name, and then whatever you're naming your object equals new constructor name, and then whatever values you're passing into that particular constructor, if any. So if we have public dog, which these are all empty or default constructors, to call it, it's going to be the class, which is dog. So the constructor and the class name are always the same. So dog, whatever we're going to name our object, in this case I chose new dog, equals new space and then dog, and then our parentheses are empty because our constructor has empty, so therefore when we call it, it has to have empty. And the same for house. It'll go house, whatever I'm calling my object, temp house equals new house, empty parentheses, or customer, cust1 equals new customer with empty parentheses. And these things here, new dog, temp house, and cust1, I just randomly pick those. Okay, you get to choose your own variable names. You just have to follow the rules of, has to start with a letter, can only contain letters, numbers, and the underscore, that sort of thing. But you can name your objects whatever you want. All right, I would encourage you not to name them the same as the class because it just gets confusing. I mean, technically I could have just called this dog, so I could have capital dog here and a lowercase dog here, but it just gets confusing when you do that. So I would recommend that you not choose that, choose the name to be the same as your class, but you can choose whatever you want to as far as your object name goes. All right. Now these are explicit constructors. So in your class, you're going to have your defined statement here and your constructor defined in there. So this is public dog, and it expects 3 instance or explicit parameters to be passed to it. But in the completely different program where you're creating your objects and you're manipulating them things, you're going to create the object, and you can do that by calling it. So again, it's class name, object name equals new constructor name, and the constructor and the class have the same name. And then I need to pass it 3 values, a string value, and an integer. So string literals are enclosed in quotes, or they might be stored inside of a variable, but they're enclosed in quotes somehow. So Fido, poodle, and then an integer value is a number. It's a whole number, so I have to give it a number. I cannot enclose it in quotes. If it's enclosed in quotes, then that makes it a string literal, not an integer, and I would get an error. All right. Here we have public house, string address, double area. So again, house is the name of the constructor, which is also the name of my class. House, temp house equals new house. I need to give it a string value, 123 Main Street. I need to give it a double value, 2300. Okay, I can't close this in quotes. It no longer becomes a double value, then it becomes a string value, and then this would not work. And for this last one, public customer, an integer, and then a string. So customer, again, the name of my constructor is the same as the name of my class. So customer, cust1 equals new customer. I need to give it an integer, which is a whole number, 123, and then I need to give it a string, which is the name Joe Smith. Okay. All right, so here we have public dog. So this is a constructor definition that's inside of the class, the data type dog class, all right? So I have public dog, string in name, string in breed, integer in age, all right? So I cannot do this, dog, new dog equals new dog, in name, in breed, in age. Okay, so I'm creating a dog object, and I'm saying here, let's give it 3 variables, the variable in name, the variable in breed, and the variable in age. So the problem I have is this public statement exists within my dog class. This statement is going to exist within a program that I'm writing. Maybe it's a pet store program where we have dog objects inside of the pet store, right? So inside of my dog class, inside of this constructor, these variables exist in name, in breed, and in age. inside of my pet store program where I'm creating objects here, these variables do not exist unless I specifically define them and assign them values. So you would have to specifically define these variables in your program, not in your class, but in the program where you're creating these objects, and assign them a value in order to be able to use them inside of this call to the constructor. Are you guys following that? Does that make sense? Yay, nay? What do you think? So are you thinking, why would I set things to an initial value like a default value such as unknown and then change it later on? Is that what you're asking? Okay. So sometimes I might be saying, all right, so let's say I have my pet store example, and I contact the pet store as a customer and I say, hey, I'm going to be buying a dog, but I don't have it yet, but I just want to set up an appointment with you. You know, I'm getting the dog on this day, you know what I mean? So I just want to set up an appointment to bring it in for an initial checkup kind of a thing. You know, I'm going to the Humane Society to pick out a dog and I want to bring it by you for an initial checkup. Well, at that point, I don't know what dog I'm getting, right? I just know I'm getting a dog, but I don't know any details about the dog. So in that case, I could create an object, a dog object, to kind of be a placeholder to say, all right, she's coming in for an appointment, she has a dog, but we don't know any information yet. And then when I show up for my appointment, then you can fill in all the details. Okay. All right. So calling explicit constructors, like I said, you don't have access to any of these explicit parameters here unless you would specifically define them. So I don't have to pass the actual values, like I don't have to pass Fido, Poodle, and the number 2. I can pass variables, but I have to define those variables and I have to assign them a value. So I could define a variable called new name and new breed and new age, such as this, and assign them a value. And then I can use those variables as input to my constructor in this manner, but I can only use them if I actually define them and I actually assign them values, or if I ask the user to input values from the console. Okay, so that's the only way that I can pass variables into a constructor. Yes. So if these 3 variables I had actually defined within my program, so let's say I'm on this statement here, and instead of new name, new breed, and new age, I define this as in name, in breed, and in age, then I could use them because I defined them in my program and they now have values and they now exist for me. So yeah, great question. Yes, exactly. So as long as you specifically define them in whatever program you're using, then they are okay. But most likely, because you don't know how a class is written unless you're specifically writing the class, that's probably not going to happen because you don't even know what the name of the instance variables are or of the explicit parameters are. All right. So testing constructors. So when we test a constructor, every single time it's exactly the same way. We're going to call the constructor that we're testing to create our object. We're going to check to make sure that that object is not equal to null, and then we're going to check each of the instance variables to make sure they contain the value that we're expecting. Okay, So if we have our public dog class, and this is the empty or default constructor because those parentheses are empty, and we know that it's the whole, we have those three instance variables, right? The name and the breed and the age. And we know that the name and the breed should be set to a default value of unknown and that the age should be set to a value of 0. We don't need to see this code. We don't need to know how the constructor itself is written to write our test cases. We know how to call this constructor, right? It's class name, object name equals new, constructor name, and then our parentheses will be empty because there's nothing in these parentheses here. So we know that. So we can create our object calling this particular constructor, and we don't see any of that code. Then I want to assert that it's not equal to null, which means it was successfully created in memory. All right, so we're just checking, does it exist out there in memory? If it does, awesome, then we're going to pass that test case. So that's what the assert not null says, is did I create it in memory? Then we can check to see, we know that the name, when this constructor finishes, should be equal to unknown, and that the breed should be equal to unknown, and the age should be equal to 0. So I can call the get methods. I can look in my class definitions and say, all right, here we have a get name method that should return me the value of the name. And I have a get breed method that should return me the value of the breed, and I have a get age method that should return me the value of the age. And so I can call each one of those methods and compare what gets returned against the value I'm expecting. So if this constructor worked correctly, I would expect the name to contain a value of unknown, so I'm comparing that. I would expect the breed to also contain a value of unknown, and I would expect the age to contain a value of 0. So I can test this constructor without ever seeing what the code is inside of the constructor itself. And this is what it would look like, all right? But without ever seeing that code, I can write these statements. You can define conditions. So our stuff that we're testing initially is very basic and very straightforward, but we can definitely define conditions. Yes, so we could say, you know, dogs are not older than 20, so we could put some parameters inside of our constructor. And so if that was one of the constraints for the age, then what we would want to do is we would want to verify that the age is not less than 0 and is greater than or equal to 0 and less than or equal to 20 or whatever constraints we have for that. We're going to do some of that week 3 in lab 3. Maybe, I think it's lab 3, but we're not going to get into a whole bunch. This first is the expected value, and this is the actual value here. So this is what I'm expecting. The first value is what I'm expecting, and the second value is the actual one. Yes. All right. So we are only 1/3 of the way done and halfway done with our time. So not a problem, guys. The more questions, the better, seriously. All right, so testing a different constructor. This is an explicit constructor that we're testing here, and we're going to do the exact same thing. We have to call the constructor that we're testing, right? So this particular constructor is expecting 3 explicit parameters, string, string, integer. So I have to call it that way, string, string, integer. Okay, so I'm calling it, and I know based upon this statement here that the first one looks like it's going to be my name, the second one my breed, and the third one my age. And you can kind of look at the names of the explicit parameters to determine that. I'm still going to do an assert not null to make sure that the object was actually created out there in memory. And then I'm going to check those instance variables. So if this one finishes, I would expect that the name is now equal to Fido, the breed is now equal to Mutt, and the age is now equal to 2. So again, this is what I'm expecting, Fido, and I call the getName method to see what does it actually contain. And then I'm expecting Mutt, and I call the getBreed and compare it against that to see what it actually contains. And then the age, I have a value of 2, and I compare that against the age. And if my constructor worked the way that I was planning, I would expect that those values would be returned and everything would match up. All right. And so we can actually see this where it's setting it equal to the explicit parameters. And what happens is when we're in the program, so we're in our test cases or our program, which is completely separate from this class here, all right, what happens is this value of Fido comes and it gets put into this variable here, in name. And Mutt, when it gets called, gets put into the variable in breed, and 2, when it's called, gets put into this variable in age. And so then the class can use those values that are contained in these explicit parameters to create that object. All right, keep typing if you have a question for me. I'll pay attention. All right, the accessor method, we're going to think of it more in terms of get methods for this class. It's going to access, retrieve, or get information from the object. So it's going to be, it's retrieving the values of the instance variables. You can also refer to that as the state of the object. The state of the object is the values that it contains at any point in time, right? So we're going to retrieve the value of an instance variable, or we're going to use that instance variables in some sort of a computation, okay? The mutator we're going to think of as a set method. It's going to mutate or change or set the value of an instance variable. So it's going to modify the state of an object by changing its data. All right, so we had a question. The assert equals is just for observation purposes. They do not handle any error handling. They are strictly to tell you, yes, something matches, or no, something doesn't match. So there's the assert equals is obviously looking for two values to be equal to each other. And if they are indeed equal, that test case will pass and you'll get a green check mark. If they're not equal, then that test case will fail and it'll identify for you what failed and you'll get a big red X to tell you that it failed. Okay, so it's a way to test your code to verify that it worked the way that it's supposed to. Okay, so the basic format for writing a method is public. Typically methods are written as public. Constructors are as well. It's your instance variables that are private. So anybody outside who's using your class can actually access these methods. Then you have the return data type. And if nothing is returned, you have the keyword void. Then you have the name of your method, and then you have your open and closing parentheses with any explicit parameters. Sometimes you'll have none, sometimes you'll have one or many. So here's some examples: public string, get dog name, and empty parentheses. So we're going to return a data type string from this, but we don't need any values to be passed to it. So this would be written as return this dot name. So we're returning the value of our instance variable. Our public integer get age, return this dot age. So these are just accessor method examples that we've written in the class in the blueprint, but when the object is created, now the object has a copy of these methods and it acts upon that particular object. Okay. Mutator methods, on the other hand, modify things. So an example would be public void, nothing is returned, set the dog name, and we're going to set it to this new value here. So this dot name equals new name. Public void set age, and we have an integer value in here. So this dot age equals this new integer value that we're providing for it. Now, again, that was defining those methods inside of the class, the user-defined data type class that creates the object, that blueprint, right? But we might want to call these methods in our other program, our pet store program that's out here, right? We might want to say, hey, she now knows what kind of dog. She's been to the pound and she's picked one up and we now know what it is and she's given it a name. So let's change the name of her object, of her dog, of her dog object. So calling this method allows us to take action. And the basic format for calling an object is down here. If it returns a value, so this first part only happens if there is a return data type. So if this data type is void, this first part right here will not exist. This only exists if this is a non-void data type, all right? So it'll be data type, which matches what gets returned, whatever name you're going to give it, equals, and then the name of your object dot method name, and then whatever explicit parameters, whatever values you're going to be passing to it. So how that looks is if we had this statement in our class, okay? Then in this pet store program that we've written over here, if we're calling this, because this returns a data type string, I have to store that. It's going to return something to me, so I have to store it somewhere. Otherwise, it returns it, and I just lose the value. So I'll say string dname equals, and assume this is my object, tempdog.getDogName. Okay. In the case of the integer data, it's returning integer, so integer dage equals tempdog.getAge. In this case, I'm setting the object, but I have no return data type, so I don't need to set it equal to anything. It's not going to return anything to me, but it does expect a string value to be passed as an explicit parameter. So tempdog.setDogName Duke in string literals, quotations to be a string literal. And then here again, nothing's returned, but I'm expecting an integer instance or explicit parameter. So tempdog.setAge sub 7. And this cannot be a string. It has to be an integer value. So no quotations. It's a numeric literal of 7. And because it's integer, it has to be a whole number. So it can't be 7.0. 7.0 is not the same as 7. So if it's a double, I can specify 7.0. But for an integer, it has to be a whole number. Okay. When we're testing these methods, it's the exact same every single time. Create the object, do any setup work if needed, call the method that you're testing, and check to make sure it did what it was supposed to do. Okay? So again, I don't need to see the code to write my test cases. I know that this does not return anything. I know that it's called setDogName. I know it's expecting one explicit parameter of data type string. So the first thing is create my object. So I chose to just use the empty or default constructor to do that. Then I call the method that I'm testing. I didn't need to do any setup work in this particular circumstance, but I do need to call the method that I'm testing. So I created the object dog1. So I need to call it from my object dog1.setDogName, and I need to give it a string data type here. So I'm giving it Fido. So if this works correctly, I would expect that the name of my dog has now been changed to Fido, right? So I'm going to do my assert equals. I'm expecting it to be equal to Fido, and then it's dog1, so dog1.getDogName, and I'm going to compare what gets returned from this accessor method against my value of Fido, and if they match, then my test case passes and everything worked the way it was supposed to. And if they don't pass, then I have a problem somewhere and I need to figure out what's going on. All right, and this is what this would look like. But again, I didn't need to see the code to write my test case. Likewise here, we have public void set age, passing in an integer value. So exact same format. Create the object. This time I chose to use the explicit constructor to create my object. So dog1 equals new dog, and I needed to pass in the 3 values, Fido, Mutt, and 2 for the age. I call my method that I'm testing. I created a dog1 object, so dog1.setAge. It's expecting an integer value. I gave it a value of 7. So now I would expect, if it worked the way it was supposed to, that my age is now equal to a value of 7. So I say assert equals 7, and let's retrieve the age and compare them. And if they match, then I pass my test case, and if they don't match, I have a problem and I need to figure out where it is. Okay, now this is a bad test case. All right, I created my object here, dog1 equals new dog, Fido, Mutt, and 2. Then I did a dog1.setAge 2, and then I did an assert equals 2 that I'm expecting the value to be returned is a 2. Any guesses as to why this is a bad test case? Well, the problem we have here is that I didn't change the value. So what if this method did absolutely nothing at all? It didn't do anything. It just, it didn't do anything at all. But my constructor worked. So my constructor correctly sets the value to 2. This method didn't do anything. And then I test it and it returns me, they match, it returns a 2 because my constructor worked. And it gives me a false positive. It makes me think, oh, well, it worked fine because I was expecting it. I told it to change it to 2. I'm expecting a 2. It gave me a 2. It must have worked. When in reality, this didn't do anything at all. So whenever you're testing, you need to change the values. So if I start with a value of 2 and I'm testing a set method, it has to be something different. It could be 3, it could be 1, it could be 27, whatever. It has to be something different. And so when you're writing your test cases for labs, I'll specifically check that to make sure that you've set them to different values so that you know for sure that your program is working the way it was intended. Okay. Now, when we're writing a user-defined data type class, which is what we've been defining with this whole dog class, the first thing you need to do is identify the data that needs to be stored. So when we're trying to come up with the code for our class, you're going to identify what data needs to be stored for that particular entity. So you're coming up with your instance variables. You're going to identify what sort of mutator methods we need, what sort of set methods we need, what sort of get methods we need, and then any other methods we might need to finish this class out. And so here's how that would look. So if we're looking at our dog class, we identify what data needs to be stored, what our instance variables are going to be. So I'm going to need one variable to, these are not correct variable names. I'm just like jotting stuff down here, okay? So I'm going to need a variable to store the dog name. I'm going to need a variable to store the breed, and I'm going to need a variable to store the age. And the data types I'm going to give them are like string, and integer. Okay, so this is kind of identifying my instance variables. So when you're thinking about writing a class, this is what you would do. All right. Then I'd look at my constructors. What constructors am I going to need? My constructor name will always be the same. It will always be the name of the class. So it will be dog in each case, but what explicit parameters am I going to pass? So I'm going to have one constructor that's my empty one, so nothing in my parentheses, right? I'm going to have one that just brings in the name of the dog. Like maybe I know I'm picking up a dog, and by golly, I name all of my dogs Duke. Every single one, I don't care what kind of dog it is, its name is Duke. So I can, or Spot, yeah, something like that. So I'm naming my dog Spot, but I don't know anything else about him, right? So I could do this constructor that just takes in a name, and then it will set my breed and age to default values. Or I had this third one where I accept in all of my one explicit parameter for each instance variable. So I'm going to have 3 constructors, okay? Accessor methods. I'm going to want to have an accessor method for each one of my instance variables. So one for the name, one for the breed, and one for the age. It's going to return data for me. So my name is going to return a string, my breed is going to return a string, and my age is going to return an integer because that's the type of data that's stored in those instance variables, but I don't need any explicit parameters for these. So that's going to be empty. My parentheses will be empty. Okay. Mutator methods. So I'm going to want one mutator method for each one of my instance variables that allows me to change their values. So I'm going to call it set name and set breed and set age. I'm not going to return anything, but I am expecting an explicit parameter. So I expect a string for the name and a string for the breed and an integer for the age. All right. So in test-driven development, what I would do is I would write my test cases first before I even write any of that code. I know what I've got, right? I know what the name of my class is. I know that I have the 3 constructors and what, you know, an empty constructor, one that takes in the name, one that takes in all 3. I know what my set methods are going to be, and I know what my get methods are going to be. I just haven't written any code yet. So I know enough information to write my test cases, okay? So I'm going to start with my constructor, and remember it's the same format when you're testing a constructor every single time. Call the constructor that you're testing to create your object, do an assert not null on that object to make sure it was actually created out there in memory, and then check each of the instance variables to make sure they contain the value you're expecting. Okay, so to test this empty one, we're going to call the empty constructor. We do an assert not null. and then I'm going to call the get methods for each one of the instance variables and compare it against the value I'm expecting. So these are the default values, unknown, unknown, and 0. Okay. If I'm testing the second constructor, this one is expecting me to pass it as one string value, so I have to call that one. Dog1 equals new dog, and I pass it a string value of Fido, which I know is going to be the name of my dog. So again, I'm still going to do an assert not null. Then on the get name, I'm going to expect it to be equal to Fido, but the breed and age will be equal to these default values. Okay. To test the third constructor, I'm passing in a value for each one of them. So I have to call the constructor I'm expecting, passing in a string, and an integer. So Fido, Mutt, and 2. And I'm just making up these values inside of here. It doesn't matter what they are. I could call it Spot and Dalmatian and 14. It doesn't matter. You get to pick those values. Then I assert not null, and then I check, are they equal to the values I'm expecting? Yes, you should write your test cases before you actually write your code. Now for lab 1, it's slightly different because we're providing you with predefined code. But typically you want to start with your test cases. And I'll tell you what, it's a hard thing to get used to, especially if those of you who have some experience programming, it's challenging to get used to this. But you will find if you do this that it is so much easier to write your code if you start with the test cases and then move to the code second. It really, because you will have worked out all the details in your test cases, and you will know where the problems lie, and then you can write your code. So really, this is where you want to start. Okay. Test-driven development for the methods. So in the methods, it's the same. We already know we know the names of the methods. We know if they return something. We know if they expect explicit parameters, and we know what their intent is. We know what they're supposed to do. So we can write these test cases without ever having written the code. Okay. And testing methods are exactly the same. Create the object, do any setup work if needed. Not always needed, but if it is, do the setup work. Call the method you're testing and check to make sure it worked the way that you're expecting it to. So to test the set name method, we call the constructor to create our object. Doesn't matter which constructor you use. We could have used any one of those 3 constructors. We call the method that we're testing. So we've got the dog1 object. We need to call it on the dog1 object. So we set the name equal to Duke. And then we check, is the name actually equal to Duke? If it isn't, then something's wrong. Same for the set breed. We call our constructor. We could have called any one of those constructors. Set the breed equal to something different than the constructor. So I wouldn't want to set it to unknown. I'd want to set something different like poodle, and then check and make sure that it did what it was supposed to do. And the same with the age. Call your constructor, set the age to some value different than the constructor, and then check to make sure did the age actually get set. All right. Once we're done with that, once you've written the test cases, now you can come back and you can actually write the code because we've kind of already fleshed out what it should do. We know that our constructors should set those instance variables equal to these different values, right? So we can write our constructor. So we can come in here. We know this is the empty or default. So we know that our name and our breed and our age need to be set equal to these values. And we can write out this constructor really quickly. For the second constructor, we know a name is coming in. The other 2 are default values. So we can write that code out, setting the name equal to our explicit parameter, setting the other values equal to default values. And for this third explicit constructor that has all 3 values, we can set it equal to the explicit parameter here. Writing the methods, again, now that we've fleshed out and written those test cases, we're ready to jump in and write our methods. So the set name method has nothing is returned, but it has a string explicit parameter. So public void, nothing's returned, set name, and a string in here. And again, this explicit parameter, you can call that anything you want to. You get to pick the name of it. I just went with new name, okay? And then I'll set my instance variable equal to that explicit parameter. For the set breed, same thing, nothing's returned, so we've got a return data type of void, set it equal to the explicit parameter, and the same for the age. Okay, For the get methods, they do return something, but no explicit parameters, so our parentheses are going to be empty. So this returns a data type of string, so we're returning our instance variable here. Breed is the same, return data type of string, no explicit parameters, return our breed instance variable. And last, our age returns a data type of integer, so integer, no explicit parameters, and return our age instance variable. All right. Whew, babies. Questions on any of that stuff? I know it's been a whole bunch, and I was kind of, like going through it quickly. You can pull these PowerPoints out and look at this again and refer to it, okay? The API documentation or the Java docs. So this is included at the beginning of your class. You're going to actually include your documentation right there prior to the instance variables and before every method. So you should have a Java doc at the very beginning, just before your instance variables and constants, and then before every method. And here's how that's going to look. So at the very beginning, you're going to have a slash asterisk asterisk. You're going to put the description of your class in here, okay? And then you're going to have an ampersand author, and you'd like stick your name there, and an ampersand version, which you could put a date or version 1.2 or something like that, okay? So this goes at the very top to define your program. The slash slash, this goes before the variables, so this defines each one of your variables. So you put a slash slash comment before your instance variables or constants, anything that's pertinent that you think needs to be defined with some additional information. Okay, and then before each method, you're going to have another Java doc that gives you a description of the method. So it's slash asterisk asterisk, you'll put the description of the method. You'll have an ampersand param. If there's any explicit parameters, you're going to have an ampersand param for each explicit parameter inside the parentheses. If it returns something, you're going to have an ampersand return. Okay, so on Lab 1, I went over it in huge detail on Tuesday. So I think Michael, were you there on Tuesday? Matthew was there on Tuesday, right? So I went over Lab 1 like for the entire hour that we were connected on Tuesday. So for Lab 1, I really recommend, I loaded the recording up. It's on Piazza, and it's out on both courses in the Week 3 Q&A. You can find the link to the recording there. So before you begin working on Lab 1, I really recommend that you take a look at that recording. And you can watch it multiple times. So there is a benefit there, but I really recommend that you go there because we are at 9:25. I did want to show you the Java docs. So back in the Week 2 Q&A session, I went over how to create so I just created like the dog class, and then this is an actual program. And I uploaded this code too to the Week 2 Q&A session. So if you wanted to look at it, you can take a look at this. But in here, you can see I've got the Java docs defined. So here's my instance variables. I have the Java docs before the constructor, and here's each one of the set and gets also with the Java doc before it. This is just a program over here. So this is a program where I actually am using that dog class. Here I created a dog object. I accessed some of the information and printed it out. I made some changes by calling the set methods and changing them to new values, and then I printed that information out. And then I created a second object and printed information out from there, calling get methods to retrieve values. Okay, and then I called set methods to change those values and printed that information out. For the Java docs, what you can do here is, because it's defined in that one in the dog class, I can come in here and I can say tools, project documentation, and you can say just show or regenerate. I'll regenerate it. And it will pop up. So it actually reads those Java docs, and I can create on this dog class here, and you can see here's the two constructors, and it gives you the format for my constructors. Here's the methods that I defined, and you can take a look. Here's the data types that get returned. Here's the name of my methods, and if they have something inside of the explicit parameters, so something that needs to be defined, I can actually click on this and it takes me down to see additional information. And all this stuff is pulled right from those Java docs. So it's kind of like building in documentation into your program without you really thinking about the fact that you're building in documentation, if that makes sense. So this is where those Java docs are kind of like awesome, especially because programmers typically don't like to document. So it's great that it's all built in and it automatically generates all this stuff for you. Yeah, it is. It's very, very cool. Okay, so Lab 1 is due next Wednesday. I'm going to suggest to you that you begin working on Lab 1 no later than Saturday. Now, you may have no problem whatsoever and whiz right through Lab 1, or you may struggle greatly with Lab 1. But what you're going to find is that the homework assignments and the labs for this course from week 4 on are not a Wednesday night start working on them type of a thing. Yeah, so and what happened is with this particular class, the course manager, so when assignments are due on Sunday, as an instructors, we have to have the assignments graded within 5 business days or 5 days. So that would mean we have to have the assignments all graded and recorded in the gradebook by Friday. And the course manager was concerned because these assignments for this class, you know, they get very detailed and everybody can use it. You know, there's no one way to write code. You can write code in a lot of different ways. So it's not like I can just make all of the homework assignments multiple choice, right? It's actual code that you have to check in and look. So it can take a fair amount of time to grade. And he was concerned that by only having it the weekdays to grade it, that we wouldn't be able to get it done within the 5 days that we're permitted to grade assignments. So he made assignments due on Wednesday so that as instructors, we had the weekend to get our grading done. But as a student, I think it puts you guys at a disadvantage because how many of you guys wait until Wednesday to start working, Tuesday or Wednesday to start working on your homework? Probably, I would say the majority, right? Because your other classes, their assignments are due on Sunday, right? So you're going to spend the weekend working on those other classes, and then Monday you don't even want to think about schoolwork, right? So Tuesday you might start working on your homework. And the issue with this class is week 3 is the end of the take it nice and easy on you. Week 4, we're going to start jumping in with both feet, and the homework is going to get more challenging. And Lab 2 will be, you'll be writing the code for Lab 2, where we're Lab 1, we're providing it. So when it comes to a lab, you really want to allocate a good, I hesitate to even give you a number because it really depends on, you know, what's going on for you that particular day or whatever, but you probably want to allocate a good 5 to 7 hours for a lab. It might take you less, it might take you considerably longer, but what I guess I'm saying is don't wait until Wednesday to start working on a lab. And I know we're at 9:31, so just one other point I wanted to make is the other thing when it comes to working on computer programs, it's really important to allow yourself some time to just step away. You know, if you can allow, you know, like if you can start working on the weekend so that if you're like, oh my gosh, I cannot figure this out, I'm never going to get it. And if you can just give yourself 2 hours to go walk the dog, go play with the kids, go watch a movie, go to sleep, wake up the next day, when you come back with a fresh mind, you may find that you're able to figure things out. But if you're waiting until Wednesday night to start working on these things, you have no step away time. And I use it all the time myself. Even 30 odd years in coding, I had a particularly challenging thing I was working on. It involved a lot of things. I'd been working on it for about a week and I was really close to finishing it, but it was it was just a struggle for me. It's like I just could not, for some reason, wrap my head around what I wanted to do. I actually set it aside for like 2 days and did not even look at this program for 2 whole days. I was like, I am not going to tackle this. I am not doing it until Wednesday. I'm not even going to look at it. And Wednesday, I wrote that code out, and like under an hour, I had finished the whole program and I was said and done. But if I had continued to work on it on Monday and Tuesday, I probably would have spent those 2 entire days fiddling with this code, not getting where I needed to do, but because I could set it aside, do other things, and then come back to it, I was able to tackle it and knock it out. So yeah, writing things out on a whiteboard is great. All of those sorts of things, because programming can be kind of the most frustrating thing you ever do and the most rewarding thing you ever do at the exact same time. So, all right, so that's my big soapbox about don't wait until the end. And also, if you wait until Wednesday night, then the odds of getting help are less, because I'm an early to bed kind of person, so I won't be available to help you. So if you can start earlier, then I'm there to be able to answer some of your questions. The Java docs, you should be able to go out and search for the Java docs, Owen, and find things. You have 8 and 10. I typically just go to the internet. I don't typically download this stuff. I just typically go Google Java docs and search right from there. But that's just my preference. All right, so that's all I got for tonight. I know it was a ton. You can definitely go back and watch the week 2 Q&A session. That one's only about a half an hour long. If you want to see how you write a class and then you write a program to use that class, you can kind of see that. Definitely the week 3 Q&A session, it's the whole hour long, and I walk through that lab in minute detail. So that would definitely provide you guys with a great benefit as far as working on Lab 1. Use your resources. Shoot me an email if you run into questions. Send it to Piazza. If you struggled with homework 2, which I'm about halfway done grading homework 2, but if you struggled with it, if you struggled, right? Call tutoring. I know it seems weird to call tutoring, and especially if you were one of those A students in high school where you never had to ask tutoring, it probably feels offensive to have someone to tell you to call tutoring. But you know what? Your tuition dollars are paying for those tutoring, right? So it's not a sign of weakness if you use tutoring. It's being a good consumer of your resources available to you here at Franklin. And those tutors are awesome. Okay, so if you're struggling on any concepts, man, schedule an appointment with those tutors and get in with them. You will never regret it. I have never heard a student say, boy, I wish I'd never bothered with that tutoring. I've always heard students say, tutoring was awesome and I wish I would have done it sooner. So take advantage of the tutoring if you feel you need to, all right? Okay, that's all I got. I'm going to let you guys go. We've run way over. So have a great night, everyone, and let me know if you have any problems, all right? Night, everyone. And Matthew, right? Whoever has the questions, stick around and we will take a look at what you've got going on.